Hi students, let us move to the second part of the topic plane. In this also we are finding the equation of the plane. Any plane drawing the perpendicular from anywhere, not from the origin. Already we discussed the perpendicular drawn from the origin. Now we are taking the perpendicular from anywhere, that perpendicular from any plane or any axis to this given plane, and we have one condition that this plane is passing through a point A. So that point A definitely has a position vector. When we join from the origin to that point, we will get the position vector, that is A bar. Small a bar is the position of the given point through which the plane is passing. Now we have the perpendicular n bar. If these two conditions are given, that means the plane is passing through the point A having the position vector A bar, and n bar is the perpendicular drawn to the plane, then the equation of the plane in vector form is r bar minus a bar dot n bar is equal to 0. It is crystal clear that the dot product of any two perpendicular vector is always 0. So r bar minus a bar, it is a vector, n bar it is another vector. When we find the dot product of them, the value is equal to 0 because already n is the perpendicular vector. Now you may be getting the doubt from where we have got this r bar. As I already told you that r bar is the position vector of any general point on the plane. The point P is the general point on the plane, A is the particular point we have taken, n bar is the perpendicular drawn to the given plane. So the formula is r bar minus a bar dot n bar is equal to 0. That is a vector form of the equation of the plane when the perpendicular and the point through which the plane is passing. Suppose we want to find the Cartesian form of this equation of the plane. It is very simple. Take r bar is equal to xi plus yj plus zk, and a bar is nothing but x1i plus y1j plus z1k, and n bar is as usual ai plus bj plus ck. Substitute them in the formula, that means in the vector form, simplify them. These a, b, c you can take either capital letters or small letters, it is up to you. We can take either capital letters or small letters. So we get the formula a into x minus x1 plus b into y minus y1 plus c into z minus z1 is equal to 0. This is the Cartesian form of the equation of the plane which is passing through the point A having the position vector a bar and perpendicular n bar. Now let us take the next form, that means the third form. This is about the plane which is making intercepts on the x axis, y axis and z axis. Suppose imagine that this is x axis, this is y axis, this is z axis. Say this hand is another plane which is intersecting or making the intercept with the x axis, y axis and z axis. Imagine that you are keeping a book at the corner of your room that will be touching the x axis, y axis and z axis. That is the plane for which we want to find the equation. So we get the formula x by a. Here small a is the intercept made on the x axis. The plane is making the intercept on x axis, that is small a. On y axis it makes b, on z axis it makes c. So we get the formula x by a plus y by b plus z by c is equal to 1. That is the equation of the plane making the x, y and z intercepts with the three axes. Now the final equation of the plane where the 3 points are given. Here remember, the 3 points are non-collinear points. The meaning of non-collinear is the points are not lying on the same straight line. If the 3 points are on the same straight line, the line will be passing through all the 3 points. So that line will be called as, that points will be called as collinear points. But here the 3 points are at 3 different places. Here one point, there another point, here another point. Like that, 3 different points we are taking. So when we join them, we will get one plane like a triangle shape. So we want to find the equation of the plane in Cartesian form only when the 3 points are non-collinear. Here x1, y1, z1 is the first point, x2, y2, z2 is the second point, x3, y3, z3 is the third point. The 3 points you have to imagine now. They are in the space, suppose. You have joined them. We will have the formula determinant of x minus x is from r bar. R bar is the general point. So that's the position vector. So we are getting the formula x minus x1, y minus y1, z minus z1. These 3 values will be in the first row of the determinant. The second row we get the direction ratios x2 minus x1, y2 minus y1, z2 minus z1. The third row x3 minus x1, y3 minus y1 and z3 minus z1. This determinant value is equal to 0. So this is the formula for finding the equation of the plane which is passing through the 3 non-collinear points. So in our next video we will discuss how to find the equation of the plane passing through the intersection of 2 planes and other models. Thank you.